mention, because this lesson is very important. It's extremely important because it's the introduction to the rules of differentiation, which are the ones that you are going to be using more as compared to finding the derivative from first principles. Right, so we have got specific rules. Now, each textbook is very different, and authors, they write the rules based on their understanding and their experiences. So the first rule of differentiation, okay, this is the general rule, right? If you are given a function, say f of x equal to a constant k times x to the power of n minus, okay, let's call it x to the power of n, like that, right? According to the first rule, if you want to find the derivative, please pay attention here. Your knowledge of exponents is extremely important when you're finding the derivative using rules. So what you do is you write f prime of x, which is the derivative. Then the next thing, you multiply this exponent n by the coefficient of x to the power of n, which is k. If you do that, you get nk times x to the power of n. Now you have to subtract 1 from this n here, and then you get your derivative. So the derivative of k times x to the power of n is going to be n times k times x to the power of n minus 1. Okay? That's the general rule, which in this case here is the first rule based on what we have here. So just to give you an example, if I'm to do an example on this using rule number 1, if I'm given a function like say f of x equal to 9x squared, like that. If I use the first rule, it means my first derivative is going to be 2 times 9, because that 2 there is like the n. The 9 is like the k here. So it will be 2 times 9, and that will give you 18x. Then you subtract 1 from it, so you get 2 minus 1, and the final answer will be 18x to the power of 1, which is the same as 18x. Okay, so now rule number 1 is the main rule. Okay, that's the main rule for finding the derivative using rules. Okay? So what you do is, if you are given the function, you identify the exponent of the variable. Usually the variable is x. That exponent, you multiply it by the coefficient. Okay? Then you subtract 1 from the initial exponent. Okay? And then you simplify it, and then you get your answer. So from now on, after this lesson, we won't be finding the derivative from first principles. We will be using rules to determine the derivative of any function. All right. The second rule. Right. The second rule. Well, if you multiply a constant by a variable, right, and you want to find the derivative of the product of a constant in the variable, the answer that you get will be equivalent to that constant. Okay, so if I give you, okay, just to generalize it, f of x is equal to k times x. If we use rule number 1, our f prime of x will be equal to, the exponent here will be a 1. So 1 times k will give you kx to the power of 1 minus 1. We know that x to the power of 0 is a 1, so you end up getting k. So the derivative of a constant times a variable is equal to that constant. Okay? So that's what rule number 2 says. Okay? So if you multiply any variable, in this case x, by any constant, and then you want to find the derivative. That derivative will be equal to the constant. In actual fact, this will be very interesting because what this means that this function here, it's a linear function. Okay, remember a linear function is of the form y equal to mx plus what? C. If the c is 0, it becomes y equal to mx. So if you compare this and that, you are going to find that your m will be equal to your k. Okay? Remember, the derivative is a gradient. The derivative is a gradient. Okay? I'm just going to repeat that the derivative is also the gradient of the function. Okay? The two are the same. It's just that the terminology used is different. The word derivative is a calculus definition of gradient. Okay? So the gradient of a linear function is equal to the coefficient of x, in this case here, which will be k. Then the derivative of a constant is a 0. So that's rule number 3. Okay? So if you want to find the derivative of any constant, the answer that you will get is a 0. Okay? What that means, if you are trying to find the gradient of a horizontal line, what is its gradient? 0. That's what rule number 3 is talking about. When it says f of x equal to k, it means we are talking about a horizontal line. The gradient of the horizontal line is 0. Rule number 2, that's the gradient of a linear function, which is equal to the coefficient of x. Okay? And then rule number 1, it's applicable to quadratic and cubic functions. Okay? As I told you, you don't find derivatives of exponential functions. That's for graduate level mathematics. Okay? Any questions before I move on to the next page? Yes?
What function did you say is 4?
What?
What function did you say is 4?
Will be the what?
The function will be.
That's not a special function, it's just a straight line, but it's a horizontal line. It's a horizontal line. Yes. The derivative is the gradient. Alright. Let me take care of. If you remember my first lesson when I told you what differential calculus is all about, I told you it's about finding gradients for functions. Okay? It's very important for you to understand that from the beginning or from now. Right? Then there are some concepts that you are expected to know with regard to exponents. Okay? So you are expected to know the following. Okay? You are expected to know your laws of exponents and your definitions of sets before you start using the rules of differentiation. So the first one, okay, the first one is that if you are given x to the power of n over a, you must know that it can be written as 1 over a times x to the power of n. Okay? You are going to encounter something like this when you are finding the rules, sorry, when you are finding the derivative using rules. Then, if you are given a constant divided by x to the power of n, it is equivalent to the constant times x to the power of minus n. This one here, it uses this law of exponents x to the power of minus n is equal to 1 over x to the n. Now, when you are finding rules, you need to eliminate all division lines. All division lines must be eliminated. All square roots must be eliminated. That's why you need to know these concepts on exponents. Also, a divided by b to the power of b times x to the power of n is the same as a over b times x to the power of minus n. So we have got that from exponents, that is last year. Today, when you go home, you must go over your laws of exponents because you need the laws of exponents for you to understand how to find the roots of, sorry, how to find the derivative using rules. Then a divided by bx all raised to the power of n is the same as a times the product of bx raised to the power of minus n. Again, this is just an extension of that rule there. Then when it comes to the square roots, you should remember that if you are given the nth root of x to the power of m, that can be written as x to the power of minus m over n, where m is going to be the numerator of the rational exponent, and n will be the denominator of the rational exponent. And then this one here and that one, they got some relationship. It's only that for E, you are going to have a negative rational exponent, which is also a very common scenario when you are finding rules, when you're finding the derivative using rules. Let's carry on. So, okay, I'm just going to talk about E, what E is saying. So E, you have got A over, that's A over the nth root of x raised to the power of m. Okay, which is, can you pay attention? You are the one who asked. I hope all of you are aware that if you are given, this is a fraction, so we can write it as A over 1 times 1 over the nth root of x to the power of m. I hope you are aware of that, right? Then once you are aware of that, it means I can write this as A times, if I use my knowledge of sets and exponents, this can be written as x to the power of m over n when I remove the square. Remember, that n there will be your denominator in your rational exponent. This m here will be the numerator. Then you use this law, x to the power of minus n is equal to 1 over x to the n. But we are moving now from the right-hand side towards the what? The left-hand side. So if the exponent was positive under the denominator, it becomes negative when it becomes part of a numerator. So this becomes a times x to the power of m over n. Okay, so that's a over nth root of x to the power of m becomes equal to that. Okay, that's it. So using that law of exponents, that this one here is very important. Sometimes it's called the definition. Okay, that's very important. We use it in calculus, okay, to convert a positive exponent, which is part of a denominator, to a negative exponent. That's why we need that. All right. So make sure you remember that. Okay. Then let me just tell you about the notations used for the derivative. First, let's start with the one that you know, m. Okay? M is the notation used for gradient. You have been taught that since grade 9. Now you have been introduced to f prime of x. It's also gradient. Okay? But that's for calculus now. Okay? U notation, dy over dx. Okay? That's also gradient. They're going to encounter it as well. Okay? I'm not done yet. We also have the differential operator d of x, capital letter D with an x as an exponent. That also represents the derivative. Okay? We also have another notation which is y prime. Okay? Y prime is also another notation. Right? Now, that notation, the y prime, the one that I just got the what are called examination guidelines, right? That y prime there, it's also acceptable in when you write examinations. So there are actually 4 of them. When I say 4, I'm saying excluding what? M. M is not a calculus notation for grading. It's these 4 here. These are the notations for calculus. Calculus notation for gradient. Okay, so I'll write here differential calculus. I don't like to write calculus because it will seem like I'm talking about geography. Right, so I'll say differential calculus. Notations. Notations of gradients. Okay. All right. Now this one, it is related to what you know, but to be honest with you, you probably might uh, have some confusion. I would say, but it's very straightforward. Remember, when you're writing m equal to y2 minus y1 over x2 minus x1, do you see that here we have got dy, right? That refers to the numerator. The x2 minus x1, that's d of x. And sometimes we write this as change in y over change in x. That's gradient. That's synonymous with dy over dx. Okay? So don't get confused. F prime of x, gradient. Dy dx, gradient. D of x, gradient. Y prime, gradient. Okay? So 4 notations for the same concept. All right? Okay? Any question?